this is very much just revision. So it's all calculations. Okay, this is a parallel circuit. In a parallel circuit, the resistors are arranged in this manner. So then, yeah, the points that are labeled, right? So this point and this point can be joined together as one point, and this and this and this all can be joined as one point. So this tree, right, can be considered as also one point. So the potential across the battery is V. Then because these points are identical, so this here the potential is the same as V, and V2 is also the same as V, so you get this conclusion. So then, okay, I didn't do it. Then a reminder, so if you have current coming out from the battery, current comes to here and you will split into two parts. So current is I1 plus I2. I'm sure we covered this earlier, but yeah, let's just do some reminder because it's quite a while since we've last done this thing. Here, calculate V. Why is it 1.5?
It's because the current split into two. Because
Okay, okay. So let's address this. Okay, it's like this. If I have two resistors, R1, R2, then R1, R2 is equal. Then current that comes out will split equally into two. So that means is I split into I half and the other split into I half too. If the two resistors are the same. So if the two resistors are not equal, the current do not split equally. So then we look at this. So this is 4 ohms, 8 ohms. So do they split equally?
no.
No. Okay. So if it doesn't split equally, so this is 3 amps. Current flow in the path of least resistance. So the one that has less resistance will get more current. So the ratio of the resistor, right, is 4:8. So it's 1:2. Am I right?
Yeah.
So in this case, right, the current will split. So current that goes into the resistor for 4 ohms, right, will be two parts, and current going into the 8 ohms, right, will be one part. So 3 amperes. So down here will be
2 ohms,
2 amps,
3 amps, 1
1
amp.
amp, 2 amp, and 1 amp, like that. So once you get this, right, then you know 1 amp goes inside the 8 ohm. So V equals to IR.
So 1 times 8.
Yes.
So 8 volt.
Okay. You can also do another method, which is find the total resistance first, then V equals to IR. Also can. So it can be done this way. Let's show you again. So 1 over R total equals to 1 over 4 plus 1 over 8. I need the calculator. Can you get this figure for me? So 1 over
3 over 8.
3 over 8. So then this will be 8 over 3, right?
Yeah.
So then V equals to IR equals to I is 3 times resistance. Then you get 8 volts. Same way. So you either method 1 or method 2. You will get the same thing. This one, V equals to IR 1, 3. Where did the 1 come from?
Because the top resistor receive 1 amp.
Why?
Then the bottom two receive 2 amp.
Why did the top one receive 1 amp? This is a different question. Is it the same question? It's a different question. So you do V equals to IR on the top one.
2.
You do this. Then after that on top is 1. Then V equals to IR this way. Like that?
Yeah.
Yeah. So you should include this in your working. If not, no one is going to know what's going on. Okay?
Yeah.
So then the effective resistance I mentioned just now. So it's based on this formula. So I'm not supposed to ask you to combine the resistors together first. Okay, so now you can combine the resistors together. Then we got P and Q down here. Then the resistors are 3 ohms and 6 ohms respectively. Means this is 3 ohms, this is 6 ohms. Then they ask what is the PD in Q? That means what is the potential difference here? Straightforward answer. What is the PD there? 9. Yes. So 9 volts here. Determine the effective resistance in the circuit. This 1 over R effective. 1 over R effective. So it's 1 over 3 plus 1 over 6 half 10. Yeah. Okay, next. What is the reading on the ammeter? So R effective is 2, means after you combine everything here, right? This is 2 ohms, 9 volts. Current is unknown. V equals to I R. R is 2. Okay, what is the reading is this one? My answer wrong. The answer is correct. So determine the current. So it's like just now the other question. So you find you either do the total resistance, then you find the total I, or you find this is 6 volts, you find the individual and then add up. It's also possible. Two ways to do it. You should write 1 over R effective equals to 1 over R1 plus 1 over R2. So it's 1 over equals to 1 over 3 plus
3
1
plus 1
over
over
6. So
equals to 1 over 2.
so then R effective equals to 2. Then V equals to IR. So I equals to V over R. So it's 6 volts divided by 2. Your this line right must be written like that 1 over R effective. If you don't write, that means your formula is wrong. Then you may get penalized for that. Okay, next. This is very simple. You see, you get 6 volts, and then in each branch, one is 1 ampere, the other branch is 2 ampere. So they ask what is the current from the source. Yep. Yeah. You see. Then what if I want you to find X and Y, the resistance? What if I want the resistance? How to find?
R equals to V over I.
So you take 6 divided by 1 and 6 divided by 2.
Yeah.
Okay. Next. Okay, so let's see. I equals to V over R. So you take 12 divided by 4, 3 amps. This 3 amps is over here.
Yeah.
Am I right?
Yeah.
Okay, so 4 minus 3 is 1 amp here, correct?
Yeah.
Then R equals to V over I, so it's 12 ohms. Okay, 3 volts. Then it's quite easy. Look over here. So we label I1 here. So I1 is V over R, so it's 6 divided by 6 is 1 amp. Then R equals to V over I. So the other one is 3 volts over 1 is working. If you just write the answer, then no one will know what's the working and can't award marks. Okay?
Yeah.
Okay, lovely. A bigger diagram down here. The drawing becomes a little more complicated. Why 4 divided by 2?
Because current equals to volt over resistance.
So this volt is the 4, and then where did the resistance come from?
The 2.
1 over 8 plus 1 over 2, 6, 8, 12. Where did the 2 come from?
The one at the side.
No, you cannot do this. Okay, so you redraw this first. So you get 4 volts, then your 8 ohms here is still there. So I1. This branch below here, right, can be redrawn into 1, 2, 3 resistors side by side. So that means it's 2 ohms here, 4 ohms here, 6 ohms here, I2. So then you can continue to redraw further, and then this is 8 ohms, and then I1, and 10 plus 2 is 12 ohms here, I2. Then you know this is 4. Then you do V equals to I1R. Because they want I1, then it's the one that is going through the 8 ohms. So V is 4 I1 times 8 ohms. So I1 will be equal to 4 divided by 8 equals to half M. Understand?
Yeah.
Calculate I2. So the drawing is like this again. So it's 2 ohms, 4 ohms, 6 ohms. Then your 4 here. So the potential difference here is 4 volts. Then the resistance in this branch is 12 ohms. So your drawing become, so how? You have to redraw and merge everything. Then you can see your answer. So I2 is V over R. So 4 over 12. Yes. Okay. Calculate the effective resistance of the circuit. 1 over R effective equals to 1 over. Why is it only 1 over 8 plus 1 over 4? What about the 2 ohms and the 6 ohms? Where did they disappear to?
Because they are in a series.
Against in series, yeah, because they are in series, but they are still in parallel. 1, 2, 3. before you do your question, you must draw it out like that. 2 ohms, 4 ohms, 6 ohms. You see, then after that it becomes, you see that one, that two are in series, right? It is in series with the bottom branch here, is series here under. So because they're in series, I add all of them up, so it becomes 12 ohms like that one. So you must add them first, not add later. You see the difference in the drawing?
Yeah.
What you are doing is your circuit is like this. You are your working shows this. The working that you have, right, is for a circuit like this, not the case. 1/8, 1 divided by that. Yeah, yes.